Okay, hello guys, how are you? Hope all is fine. And in the continuation of delivering the concepts, we are actually delivering or providing you a conceptual framework regarding aerospace aerodynamics. And in this video, just in continuation from the previous video, I'm just going to provide you a demonstration about an experiment and or test which is about static, lateral, and directional stability, and it's about steady coordinated slip without a side slip, and at that would beta would be obviously 0, and the side slip is just like that. If for example, if I take it like this is aircraft, and if it's moving sideways and also it is moving forward, that means it's in a side steady slip position. Okay, and the steady coordinated slip, that is without side slip, and that is side slip that we're talking about. This is side slip, and when we're going to talk about the steady coordinated slip, that would be without the side slip, and that condition would be beta is equal to 0. Okay, so the aim, well, first of all, what is the aim or the purpose of this experiment? As we know, we have to calculate the aerodynamic properties as well. We have to calculate the weight factor as well, and we have to calculate by providing all the assumptions. If we find that our result is true, absolutely true, we're going to use it for our, then that means that the assumption is absolutely right and our experiment is absolutely true for the said assumptions. That if there is some variability, that means that our assumption or experiment is not correct. That is why we are doing this experiment. We have equipped ourselves in the last video that we normally take some instruments like indicator, a speed indicator. We want to have the gauges as well, and we want to have the stopwatch. We want to have very different sort of the instrument for the pressure as well. That normally is in the gauges. But in this experiment also, we can assume that we want to have a stopwatch in front of us, and obviously we want to instruct our pilot, or by mutual understanding that yes, you have to fly at a certain angle, which is theta, or you have to at 90 or 180 degree, and afterwards we can going to by our assumptions. Obviously we're going to say that our assumptions, and also by the mutual understanding between the between pilot and between us as an experiment or doing the experimentation. So obviously when the results are absolutely true, we mean that our experiment is absolutely right. The aim of this experiment is to determine the lateral and directional control angles for trim under steady coordinated turn. And normally we if actually aircraft is turning, okay, in a coordinated turn, obviously, and what are that is the steady coordinated turns. Okay, and what will make up the equation for that? If you want to have that discussion in terms of centrifugal force as well, we have to discuss a centrifugal acceleration normally, because it normally points towards the center in turning, and it's a steady coordinated turn. So that is why we have the velocity coordinates as well, and we have the different components of the aircraft in normally providing the aerodynamic properties or the aerodynamic force that may help us to get a steady coordinated turn. But this study also helps in estimation of some of the directional and lateral static stability derivatives. of aeroplane in approximate manner. Obviously, as from the engineering point of view, we are here to find the approximation, and the best possible way of getting the approximation is through derivatives. That is why if we're going to get an equation, and if we're going to have that derivatives, normally we're going to check that what are the approximate values and what are the major contributors of the force, okay, which is the side force. And we're going to explain it further. The side force equation, which is Fy for steady coordinated turn, is as follows. So there is a centrifugal force, there is a centrifugal acceleration, and for that reason we're going to calculate we're going to actually say an equation which is of you can say the side force equation, which is Fy, and Fy will be represented as like this. If it's not set so tidy, please actually mention it in the comment section so that obviously I can provide you some better representation. But right now, if you can see, Fy is equal to half rho v of turn, that is velocity because of the turn, square s, and you Cy of wing pb over 2v by turn, and plus c yr and rb over 2v by turn, that is r by rudder, and c y by lambda, oh sorry, beta, and beta is and also is beta, and plus cy lambda a into lambda a plus cy lambda r into lambda r, that is because of rudder. And this is whole equation. Now this is the aerodynamic components, okay, and we're going to see that how it is affecting the force, and how well the components are actually contributing towards producing the force, okay. So normally you have to see that steady or the that is normally the position. If you want to, I've discussed earlier what is the steady turn. So that is, I have discussed it. If the angle, normally it is also mentioned like this: if the angle is in this direction and it's moving, okay, and in a steady turn position, okay, and against the direction of wind, this is the runway, and normally this is the position in a steady turn position, and it's moving like that. It's moving like in a you can say in a turnway, and in the obviously creating a turn and moving in that direction in a steady turn position, or a steady turn approach. And Fy, because we have that equation, and normally Cy because of the wing, okay, we have to consider the three axes: x-axis, y-axis, and z-axis, that is of aircraft. And when we're going to do normally the explanation would be like this. If we have this sort of an aircraft, this is the wing, and this is the tail, and this is the wing, and this is x, this is y, and z is under this page, and so we get a direction because that was negative y, okay. And because of the component of p, which is of the tail, because tail is in the vertical position, vertical tail, and the component p, which is of tail, actually is balancing in the negative direction, so that would be in a negative, that would be negative. And beta, obviously the beta is also being balanced by negative y, okay, because there is a turn, and obviously when there is a turn there is an angle, and there's beta is 0, but obviously because of the velocity factors, and there is a negative y as well because of the tail, and that will also be because of the wing, that will also be negative. and for that we have to assume that is approximately 0, and the components available would be CYR over 2VT, that is present because R is obviously present, and creating an angle producing the velocity moving in turn, and also Cy lambda R by lambda R, that is also present, and plus mg cos of theta into sine of alpha, I believe that is m, that is because of the weight factor. This is the weight factor, and that is the aerodynamic forces. Okay, and the weight factor has been balanced by the lift factor, and that too actually equal to the y, which is obviously in the vertical position, actually corresponding to the lift as well. So you can say that is a relationship between the weight, okay, and that is CVY, that is the non-dimensional component of force Fy. Okay, that is the non-dimensional component of force, that is Fy, and we have to take it Vt as well, and which component, because normally these velocity components are also present, that would be x, y, and z. Moving in turn position, the components will change, the velocity, if the direction of the velocity will remain same, but the components would vary from one position to another position, in case obviously if it's turning in a steady coordinated way. So let's see, when we're going to see that, that is the v component because of the local v component of total Vt, okay, that would be because that v is, or v naught is at local y-axis, and that component is of Vt, and that u is of it is a local x-axis component of this Vt, and Pw is the local z axis or z axis component for this Vt, which is the total velocity because of the turn. So that is how you're going to see m is equal to v naught plus ru minus pv. This factor is negative because of p. I mentioned earlier that because then we have mentioned it is minus, and also we're going to say this r is positive, you don't need to worry about, and this mv is equal to that v is also over here. Okay, so just combining it, we have got this v plus ru minus pw. Rest of the figures are absolutely near to 0. We have to ignore this one because of the steady coordinated turn. This factor is 0, and this factor would be 0 because of beta is equal to 0. This factor is 0, this factor is 0. We have to ignore this one because it's very small. The only factor present would be this and this. Okay, when we're talking about the aerodynamic forces apart from this weight factor, and when we're going to solve it out for the equation or for the velocity equation, we get this one relationship. For steady coordinated level turn with a small bank angle, which is v is equal to 0 and p is equal to 0, r not equal to 0, and beta is equal to 0, no slip. Okay, beta which is theta is equal to 0, and also this I is less than equal to 10. Okay, we have to consider that this turn angle is also very less than equal to 10 degrees. Okay, theta is equal to, because placing over here, just I'm talking about over here, this one is equal to 0, okay, and this one will be less than equal to 10, and we have to assume that above equation gets simplified like this. Okay, mg that one, because of very well less than 10, that would be mg5 plus half then adding this one, half rho vt squared s, and getting these factor. You can ignore this one if you want to, as I said earlier, and the result would be just solving it out, and the result would be mrvt. That would be the overall result. Okay, that would be the centrifugal actually acceleration, and also we got in terms of the centrifugal force as well. Okay, so that would be MA or MRVT. We have to solve it for the acceleration, then and it would be turned into this MRVT. And as you know that MRVT, you can have solve it out for MRU in case of this, because MRU, that would be the condition, because we have to ignore this one. Okay, V naught is equal to 0. Okay, and P is also equal to 0, so these two factors will be 0, just remaining MRU. We have to replace U, it is a velocity, but we have to replace it for what? A velocity due to the turn, and that would be MRVT. I have noted down, I have explained as well, note that U is equal to velocity due to turn. So this whole equation is now been simplified into this one. Okay, obviously we have removed this this as well, we have removed this as well, this as well. I have, in case you can show over here, but obviously this and this would be remaining factor. And at the end, because this whole together has been reduced to this, I will explain. You can actually just simplify it. If you want to have simplified over here, then you can write this equation, and this equation will be again simplified by this 0 and this 0, MRVT, neglecting see this contribution shown small, so obviously I've discussed earlier. So we have mg of pi into mvt of r. So cutting this, and we are solving this, we have this, or also we can solve it for g, so it is vr by pi, and the g value needs to be 9.7 to around about 9.8. that if that is condition is true, then means we, with all the assumptions taken into considerations, are absolutely correct, and we can say that our experiment is true for the steady coordinated turn with no side slip. Okay, and that is our conditions. The assumptions are in front of you, and we have we have explained the procedure as well. We have explained, but obviously this experiment needs to be done in a practical way. If you have a field, if an aircraft, you can, with the help of a stop call, with the help of the instructor and the pilot, you can actually perform this experiment live. You can record the data, and you can test the analysis and analyze the assumptions, and if it's correct, then obviously this needs to be this one. G needs to be 9.7 to 9.8. If this is absolutely right, that means that all the assumptions, if it's angle less than equal to 10 degrees, or if it's 0, theta in terms of 0, and providing all the assumptions and all the components which are very, very small, concerning it to be, or neglecting them, or actually approaching them to be 0, then obviously we can say that our approximation of actually, or the approximation of the derivatives for the various components of the aircraft, and also because of the force, because of the velocity, and in a steady coordinated turn are absolutely correct, and we can say that our experiment is logically and absolutely right. But this may also actually add up to further concepts, the further derivatives, the further simplified versions. We can roll derivatives, and also some other concepts that will be the extended version from this experiment, and we can actually explain it in another video, or in our next video. So I hope that if you have any questions that may come across because of this experiment, which is a generalized experiment normally present in the course books, and I've actually taken it from that course book, and obviously it is also in the IIT Kanpur, and also been in one of the lectures of Professor A.K. Ghosh. You can also take them the links as well. If you are interested, we can provide that. But right now I've explained it just with the help of the notes, with the help of the explanation that what is the purpose of this experiment, and how we can actually get the static, literal, and direction stability in terms of steady coordinated slip, and that is our experiment on the basis. I have explained more than once what is the purpose of the experiment. If you have any questions, do mention in the comment section, and I will be waiting for the subscription, likes, comments, and pressing of the notification button as well, and hope to see you with the continuation of our concepts regarding aircraft. If you are interested in ordering some of our actually services as well, you can go to the link and you can see that what our services are, so that you can order if you are interested, or you can actually share the links as well, and if anyone is interested, we can provide the offers or the services at a very economical and negotiable rates. Till then, thank you very much, take care, and have a nice day.